Hello everyone and welcome back to the final episode of the Basic Blueprint series for now. Today we're going to add some engine sound effects to our Hovercraft. We also create a minimap widget that appears when we enter the platform. So open the Hovercraft blueprint and switch to the viewport. Add a spring arm component. Then add a scene capture component 2D to the spring arm. This is basically the camera that provides the view for our minimap. To make it a top-down view, select the spring arm and rotate it 180 degrees on the Z-axis and -90 degrees on the Y-axis. Set the target arm length to around 1500. To prevent the minimap view from jumping around when something gets in its way, simply disable Do Collision Test. For the camera itself, we have two projection types: perspective, which gives us a three-dimensional view, or orthographic, which creates a flat two-dimensional view like on traditional maps. Now scroll down to the scene capture section. Here we need to create a texture target from the camera's view, so we can use it inside the widget we are about to create. Click on Render Target to create a new one and name it Minimap. Now right-click on the newly created render target and create a material. Open it, select the output node and change the material domain from Surface to User Interface. Reconnect the texture to the final color pin. So this is our minimap view. It's a little too dark for my taste, so to make it a more independent from the lighting and shadow situation of the scene, we disable ambient occlusion and dynamic shadows in the camera settings. And to make it even brighter, we can simply multiply the texture by maybe 3 in the material graph. Now right-click in the content browser, go to User Interface and choose Widget Blueprint. Select User Widget and name it Minimap Widget. Open it. The first thing we need to add is a canvas panel. This represents our screen. Next, add a border component for our map image. Then add an image component as the child of the border and assign the material we just created as the brush image. In the Details panel of the border, set your desired size for the minimap. Also set the width of the border in the padding section and your desired color under brush color. Then place it where you want it on the screen. To make sure the map scales correctly with different screen sizes, we adjust the anchor points of the border by simply dragging them into its corners. Compile and save. Now open the Hovercraft blueprints to activate the widget in our game logic. Create a custom event and name it Minimap On. Also create a new Boolean variable to check if the minimap is already on screen or not. Just name it Minimap Active. Drag it into the graph and add a branch node. If the condition is false, meaning the minimap is not active, we add a Create Widget node. The class is simply our created widget and the owning player is the player controller. Now we need to add it to the viewport, so drag the return value pin out and search for Add to Viewport. Sometimes it's really that simple. Promote the return value to a variable so we can store a reference to the created widget and name it Minimap Widget. Finally, set our Minimap Active Boolean to true. Now create another custom event and name it Minimap Off. Add a branch and check if the minimap is currently active. If it is, drag in the stored widget reference and call Remove from Parent. Then set the Boolean variable back to false. This way we only remove our minimap and not every widget on screen. Now we can call these events. I want the map to appear when entering the platform, so I call the Minimap On event right after the lights turn green. and the minimap off event right after the lights turn red. Compile, save and test it. And it works. But because our map camera is a child of the platform, the random hovering rotation also affects the camera. So let's fix that. Create a new custom event and name it Correct Camera. Add a set world rotation node and choose the one that already has the spring arm assigned. Split the new rotation pin and set the Y rotation to -90 and the Z rotation to 180. If you want the map to rotate together with the hovercraft, we need to add the current rotation value of the platform to the X rotation of the spring arm. Otherwise, you can just leave it at 0 for a non-rotating map. So connect the Z rotation of the platform to the X rotation of the spring arm to make it work correctly. Call this event at the end of the hovering block. Now the minimap stays perfectly stable. Okay, let's quickly add an engine sound effect to our hovercraft. I got this sound from freesound.org. I simply cut off the beginning and the end to create a loopable sound. Right-click on the audio file and create a sound cue. Open it, select the wave player and enable looping. Add a new audio component inside the hovercraft blueprint. And set the default sound to the sound cue you just created. Instead of just turning the sound on and off, I want to control its volume based on the height over ground and its pitch based on the forward speed. First, go to Event Begin Play. Drag the engine sound component into the graph and add a play node. Now our sound effect is constantly looping. We want to make sure that the volume is 0 when the hovercraft is landed. For that, we need a state variable. Create a new Boolean variable and name it landed. Compile and set its default value to true, because the hovercraft should start in a landed state when the game begins. Then create a new custom event. Name it Play Engine Sounds, for example. Add a branch to check if the landed state is true. If it is, get the audio component and add a set volume multiplier node, leaving the value at 0. If the landed state is false, get the height over ground, divide it by 100, add a min float node, and depending on the volume of your audio file, set the maximum value to something like 1.5. Then set this value to another set volume multiplier node for our audio component. Then call this event at the end of the minimap block. To set the landed variable correctly, we need to add some logic to the up and down movement. We can simply check if the max speed up-down value is greater than 0. If it is, we set the landed state to false. At the end of this block, we already have the branch that checks if the sweep hits. So we can set the landed variable to true when the hovercraft touches the ground. Now the engine should fade in and out while starting or landing the hovercraft. For the pitch control, go to the speed control section of the blueprint logic. Drag in the audio component and add a set pitch multiplier node. Connect it right after set forward speed. Here we can get the current interpolated value of the forward speed, which is somewhere between 0 and our max speed of -100. I want to increase the pitch up to a maximum of 2. So divide the speed value by -25 to get a useful, positive result. And I also use a clamp float node to make sure the pitch never goes below 0.5. Okay, it works as expected. It's maybe not game ready yet, but you've learned how to use audio components inside your blueprints and how to work with widgets as well. For now, this series ends here. With everything you've learned since part 1, you are now able to build your own simple blueprints. I hope this series helped you really understand how blueprints work. Take a look at this, the complete Hovercraft event graph. And now you can say that you understand every single node in here. If you would like me to continue this Hovercraft series, or maybe start a completely new project, if you have any questions or want some specific Hovercraft features, just leave your ideas in the comments section of this video. I will read every comment. Cheers!